Welcome back to Creating Stuff with Jim. I'm Jim, and it's time to create something. In this episode, we're not out in the shop, we're actually in the office today. So this is going to be an episode where I want to give you a brief introduction on how to use CAD, or more specifically Fusion 360. You might have seen me use Fusion 360 in some of my other videos and some of the 3D models that I might have shown you, along with all the parts that I've cut out on my plasma table. So you can do some amazing things with it. And why did I choose Fusion 360? It's quite simple. It was free. So for home hobbyists, you can use it free of charge. They just lock you out of a few features, which is not that big a deal. Anyways, this is not going to be a full tutorial on how to use the whole program. This is I really just want to show you that it's not, there's nothing to be scared about this. It's 100% learnable, and there's a lot of resources for knowledge out there that you can get. Like I said, I'll be more than happy to put some links in the description on places where I found a lot of information, and actually a lot of sources that I more or less learned how to use Fusion 360. But this is a very powerful program. I really like and enjoy using it, and so let's get into it. All right, to get started, whenever I learn something new, whenever I have a practical application, to me it makes it a lot easier. So that's why we're going to start this. This is just this rectangle steel bracket with 4 holes in it. We're just going to use this as a test piece, and all we're going to do is we're just going to duplicate this on the computer. We're going to transfer this to the computer, and I'll get to show you a few little tricks I've learned along the way as well. We first got to measure, and the tools that we're going to need some tools to do this, and one of them is this is a digital caliper. Works very well. These are relatively inexpensive. You can get them for like 15-20 bucks. They work very well. But to do this particular piece, I actually have 2 of them I'm going to use. This is a 6-inch version of it, and then I got a long 12-inch version of it. And I got these just because this piece is just slightly bigger than what the small calipers can do. So now we're going to first measure, see what the diameter of the holes are. So all right, that looks like a 1/2-inch hole. So I'm going to put a note over on my piece of paper. Yeah, we have 1/2-inch hole. That was one, but we're going to go ahead and verify. We're going to check all the other ones. Yep. 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 We'll call them 1/2-inch holes. That's excellent. Okay. Now that we have the holes, that we know the actual diameters of the holes, now we're going to do the large diameter of this. So this is where I'm going to go to my large caliper, and also I did zero it, so you might want to zero it before you start. All right, we're going to call that 7 inches. So we're going to go over here. And we're going to write that down 7 inches. Now we're going to measure the other dimension. And that looks like that's going to be 5 3/4. So we're going to write this dimension down. All right, so So we're 7 inches wide, 5 3/4 inches tall. We've got 4 1/2 inch holes, and we're going to just do a quick make sure that everything is symmetrical. Yep. Alright, since all the holes are symmetrical, and so now we have to determine the bolt pattern. So once again, they're all symmetrical, so that makes it a lot easier. Now I'm going to show you a neat little trick of mine, is because we have to figure out how far apart this hole is to this one, which will be the same as those two, and how far they are apart from this one to this one over here. So this is actually a very slick trick. So we gotta go to the big caliper. So, and what we're going to do, since we're looking for the center of the hole to the center of the hole, we're actually going to do a slick trick with this. So since you're only going to get, we can't know for certain exactly where the center of that hole is. So what we're going to do makes it very simple. Is we're going to measure from the very outside to the very outside, and then we're going to subtract the diameter of the hole. So in essence, we'd be measuring from this point here to this point over here. So, and how's an easy way to do that? It's very simple. You start off I'm zeroed out. I'm going to set the caliper to the size of that hole, which is about a 1/2 inch. I'm set with it set at the diameter of the hole. I'm going to zero it out. So I'm back 0 again. And then I'm going to measure it, and it is 5.5 inches. So we come over to our notes, 5.5 inches, and that center of the hole to the center of the hole. Alright, so if that's 5.5 inches, let's just go ahead. Let's do a quick verification on this, just for eyeball's sake, because I've done a lot just with eyeballs, but eyeballing stuff before my vision got to where it is now. But so anyways, right now I've got my small caliper, and I'm setting it up to 5.5 inches. I was going to say, that looks like that's dead center in both holes, wouldn't you think? 5.5? That's pretty easy. So when you want to measure the center to center of holes, measure one hole, zero the caliper out, and then measure the full width, and that will remove the width of one hole, so you actually get center to center. Or it actually an easy way to measure that specific measurement right there. So, alright, so that's 5.5 this direction. Now let's go ahead and do it this way. Now this is small enough where I can actually use my small calipers. So once again, I'll tell you what, I'll go back to the beginning. Is zeroed out. Measure the diameter of the hole. Zero it. Then measure the full diameter. We're looking at 4 inches. So then we come over here to our notes. So 4 inches. All right. So we've made our notes, and then also once again, showing you how to use CAD. A lot of times I don't even have to write it down, because that's the neat thing, because I have a computer out in the shop, so I can actually be working with a piece of equipment, designing a bracket, and I can actually just measure it and input it directly into CAD without having to write it down. But I'm just doing this just to show you just for illustration's sake. So, anyways, but we got our notes down. 7 inches long, 5 3/4 tall. Bolt pattern is 4 inches by 5.5 and a half, and the bolt holes are half inch in diameter. And then these radiuses. Well, I guess I got to talk a little bit about radius. And the radius is going to be a little bit of a guess, but that's okay. Because the radius is all this really is decoration. So, but anyways, but the radius of this is basically, the radius of it is going to be from the edge where it stops there all the way to that face there, and that looks like it's going to be about. It looks like it's going to be another 1/2 inch. So, and we'll do some 1/2 inch radiuses on that. So. All right, well, I think that should do it. So now we're going to switch over onto the computer and go from there. All right, we're going to start this out. This is what the screen looks like when you open Fusion 360, and this is where we're going to start from. So now we're going to draw our sketch. We're going to draw the simple sketch of the plate that we just measured. So we're going to start up here on the left, and we're going to click that says create sketch. We're going to click that, and we're going to start our sketch. Now you're going to notice you have something that you have to click on. Is you see you have these 3 panels right here, and basically these represent the 3 planes that you can put your sketch on. So this sketch right here is the one we're going to be working on, and this is the XY plane. Basically, this is on how you drew the drawing on the piece of paper. This is exactly how we're going to view it. This is like the drawing was flat on a piece of paper. You're looking down on it. Now, if you pick this is the XZ plane, and this is drawing like you're looking at a wall. So, like I said, don't let them get confusing. But I generally work in the XY plane, and the biggest reason I do that is because I use this a lot for my plasma table, and this is the only axis it can work on. So it's only a 2-axis. It does have Z-axis, but that's only to retract the torch so you can cross over a cut. So anyways, we are in the XY plane. We've started our sketch. Now we're gonna start by drawing a simple square to represent the outline of our part. So we're going to come over here. You have many drawing tools, and like I said, this is just a very small little bit of what 360 can do. There's a lot more tutorials. This is a very, very powerful program, and there's a whole lot more, but I'm just showing you that it's not hard. There's nothing to be afraid of. You just have to use it and practice with it is the biggest thing you need to do. And the biggest thing that really motivated me to learn this is just because it had a practical application of working with my plasma table, and it opened up my fabrications that I could do so much more with a lot more precision, and it really made a very big difference in what I do. So, all right, back to drawing our sketch. We're going to draw the basic outline square. And basically what we're going to do is we're going to draw a center rectangle. That basically all this means is the rectangle is going to start from a center point. So I'm going to click, and then we're going to start to draw a square. So now our dimensions is we're doing 7 inches wide. Now keep in mind, I can move this with my mouse till I have the exact measurements I'm looking for. But to do it a little quicker, you're going to notice on the width of the square, that up on top, right above where it says constraints, it's highlighted and it's 4.2 inches. So since it's highlighted, that's going to be 7 inches. So I'm just going to press the 7 key. It's going to snap it to 7 inches. Now I'm going to press the tab key, and that's going to toggle me over to the height measurement. So that's not going to, now it's got 1.8 highlighted, but we want that 5 3/4 of an inch. So we're going to type 5.75. Now, excuse me. Now we have the square of the dimensions we are looking for, and left click the mouse, that locks it in. There we go. This is now we have our basic square. Now I will point out that these red dashed lines are called construction lines. Is the construction lines behave regular than regular lines. And so when you do create parts off it, these are only used for setting geometry and things to that effect. They don't affect the end result. The biggest thing you have to remember is when you export this sketch as a DXF file, you have to remove all construction lines, because when you export it as a DXF file, every line on that drawing turns into a real line, and automation gets very confused by that. But I will show you some examples of that in some future videos, but we're going to try to keep this simple. So, but now that we have our outside of our square, now we have to do our bolt pattern. Is luckily we measured it, and basically we're going to start the bolt pattern with yet another rectangle. So we're going to go back up over here, we're going to click another center point rectangle, and the bolt pattern is 5.5 inches by 4 inches. So we're going to go right back here in the center of this rectangle, and we're going to open it up. Now the width of it, the bolt holes, and this is the dimension from center of bolt hole to center of the bolt hole, on the width of it is going to be 5.5 inches. So we're going to go 5.5. All right, now we're going to tab. We're going to go to the other measurement, and the height of the bolt pattern is 4 inches. So we're going to hit 4, left click, locks it in. And also another quick note, if you see stuff marks like that, those are called constraints, because that is showing that that line is parallel to that line. They have different sayings, they have different ones that have different meanings. I don't want to go too in depth on this video. I'm trying to keep this basic. So basically I'm going to click over here and I'm going to turn constraints off, so less confusing. And now all you have is our dimensions. Now if I want to get rid of the dimensions, over here on the right you see a dimensions, I'll uncheck that and the dimensions go away. So but I'm going to leave dimensions on for right now, but to alleviate some of the confusion is just all you have to do is click on one of these dimensions, and you can pull it out and you can adjust it so it is not confusing and it's eye appealing. So we're going to do that on this other one just like so. Now you can clearly read them and see what they are. So now this center rectangle is going to define where our bolt pattern is. So now the bolt holes are 1/2 inch holes. So now we're going to go through and we're going to center each hole on the corners of this inner square. So to do that, we're going to come up here. We have our center diameter circle drawing function. You click on that. Now you come down here, and when you see the square box around your cursor, so like right here there's nothing, but when you hit that corner it goes a square box. That means that you're centered on where those lines intersect. Same with down here, that's where they intersect. So that's the point where I want the center point of my circle. So I'm going to left click that. It's going to open up and give me a choice to choose a dimension. So it's going to be 1/2 inch. So we're going to punch in 0.5, enter for 1/2 inch, and that is our hole. And then another note is, if you don't have a mouse with a thumb wheel, it's time to get in the new century and get one, because that's the best way that this program works. Is you need a thumb, because when I'm scrolling my thumb wheel on my mouse, I zoom in and out. So a lot of times, so you can zoom in so you can see the details and see exactly what's going on. And when we go clean this up, you're going to see how much of a difference that's going to make. So now we're going to go ahead. Now I'm going to zoom out, and we're going to put the other holes in there. 3 more 1/2 inch holes. All right. So now we have, this is starting to get a little confusing. See all the dimensions on there, but tell you what, I'm going to go over here and I'm going to turn these dimensions off. And so it doesn't look quite so confusing. So as you see, we now have our square. And also the other thing is when you press the thumb wheel, or the wheel in between the two buttons, is when you press it, that's how you can scroll around it. So you can scroll, zoom in and out, then you press it and hold it, and then you can move your object, move your sketch around. So now that we have our holes, our border, and our 4 holes placed in there, now we want to round the corners. So to do that, we have this as the fillet function. You click that. I'm going to click this line and this line, and that's going to give you the arc. So now you see highlighted. You can punch a numeric value in there, is one way to do it, or you can grab this arrow and you can adjust it to what you like. And the right now for this design, this curve is really just aesthetics of how it looks. But I did take a measurement off the steel plate we're copying, and it's going to be 0.5, a half inch. So push the value in, hit enter, and then now the corner's rounded. And we're going to do that to the rest of the 3 corners. And then since we know the exact value, then I can punch 0.5 for each corner. And there's also, there are many other tricks for doing this. I'm not going over all of them. This is a relatively simple way to do it. Like I said, this is just a very basic use of Fusion 360. Once again, I really just want to show everybody that there's nothing to be afraid of. This is a very powerful tool, and it's not hard to use. So once again, I mean, I can draw on this better than I can draw with a pen and paper, and definitely better than my handwriting. So that's for another story. So now we're going to clean this up a little bit, because we need to clean this up so it looks cleaner. So we need to get rid of our construction lines and some of our extra lines. And this inner rectangle we used, we really could have done that out of construction lines, but I didn't. It's what it is. So as you can see, as I'll show you, when you roll your cursor over, you see how it highlights where the rules, where it stops where it highlights on the regular lines, but on the construction lines it ignores those. And you're going to see where that comes into play here in a little bit. So now we're going to go to the trim feature, the scissors up top, and we're going to highlight that line right there. We're going to get rid of that. Like I said, we're going to start cleaning this up. So now I got rid of all those. I'm going to hit the escape key so I can clear it. And now you can see how I highlight it. It highlights a lot different. It ignores the construction lines, and since I got rid of the regular lines, it highlights the whole thing, and it simulates the steel plate that we measured. But we're still not done cleaning it up. So we're going to go back to the cut feature. We're going to go ahead and remove all the unnecessary lines that we don't need. And like I said earlier, and I will show you in another video, what happens when you export this as a DXF file. Excuse me. I'm going to show you in another video where you export this as a DXF file on how all of these construction lines will look like that. It will look like a regular line, and it's going to cause you problems. But I'm going to talk about that in another video. So now I'm zooming in and I'm deleting everything. But now you see when I delete something, it doesn't delete what I originally drew. It goes up until it meets a line that intersects it. So you can even see right here, when I deleted this line, it stopped right there at the construction line. That's part of how construction lines work. So, but when I highlight this, see the orange spot right there, I'm going to left click, and the spot that's highlighted is going to disappear. And we're going to do that, and we're just going to keep doing that, and we're going to clean everything up. So, and sometimes you'll have little pieces left over. And once again, in a future video, I'm going to show you how some of those little pieces left over can cause you problems. So, but once again, we're going to clean this up. And see, see if you zoom in, if from a distance, it doesn't look like much is there, but got two little stragglers right there, which in some applications that won't hurt you at all, but in others it will. So, but like, once again, I'm going to try and show you. Hopefully, you can avoid some of the mistakes that I've made. So, because unless I had a learning curve, but the biggest thing is not to be afraid of it. And I say, once you learn it, it's like I said, to me, it really makes things I do a lot easier. All right, that's looking pretty good. So now that we have our plate drawn, now I'll give you another quick example of like the plane we drew it on. Is you see how we drew on the top? This just changes the view of it. So, and you can, on this little cube up here, see we're looking at, there's nothing to look at, it's just a pencil drawing, and then we're looking at the underside. If you ever get lost, just click the home, takes you back there, and you can find your way back. So now that we have this drawn, you got to ask yourself, it's like, okay, I drew this, but now what am I going to do with it? It looks really cool on the screen, but what good is this to me if all it is on the screen? Well, that's the beauty part about it, is this opens up so many more possibilities. So just using a hypothetical is, we'll just say this was part of a larger part, even though yes, we were copying that square plate with the 4 holes. But say like we were making a bracket that was going to bolt onto those 4 holes. So we now have a drawing that we can cut out to fit those 4 holes. So now, like I said, I have a CNC plasma cutter, so I can upload this file and I can cut it out, and it will bolt directly to the plate that we just measured. But the other side of it is, not everybody has a plasma table. So one thing that we can do is there are online services out there where you can upload a DXF file. So basically, you're going to highlight, when you come over to your drop down menu on your left, you're going to right click the sketch, and you down here, I have it highlighted, you can save this as a DXF file. So when I do that, if I save it as a DXF file, I can upload that file, which is this exact drawing that you're looking at on the screen, and I can send that to a service that will laser cut that out of any type of material that I desire. It can be steel, stainless steel, aluminum, birchwood. I mean, they have a plethora of materials that you can choose from. So, and I've had a lot of success using this. So I don't even have to have a plasma table. I can send it out, and I can send it out and have somebody else cut it for me. That, and also I do in the area I live, I know there is a shop that is currently in the process of setting up their own plasma table, which it's not functioning just yet, but I should be able to draw something when they're up and running. I should be able to send them my files, and they should be able to cut out what I need. So where I don't have to wait, where I don't have to send it out and wait for it to get shipped in, I can get it a lot quicker turnaround time. So that's the downfall about using the online service, is they do premier work. It is absolutely beautiful work, but it takes a minimum of 2 weeks. I've had it up as long as 3 weeks, depending on the material you're getting cut. So, but that's one way that you can do this. You can do that. Another thing you can do is you can print this sketch out on a piece of paper with your printer, and you could actually have a paper template. Unfortunately, to do that, you actually have to pay for the subscription, because the free version of it, they won't let you print it out as a PDF, or they won't let you print it out. The only way that I've been able to print it out is you have to, there's a back way to do it. You actually have to print the screen, but the problem I've had with that is it doesn't print to scale for some odd reason. I guess that might be something on how they do to prevent you from doing that. But if you get the paid service for it, then you could print that out, and you could cut yourself out a paper template. That works out well. But there's still even more than that. Because there's actually a lot of stuff I really want to share with everybody. I can't get into one video. Like I said, I'm just giving you enough just to tease you a little bit, just so I say you at least try for it and use it yourself. But what we're going to do now is I'm going to go back, orient it to the front. I'm going to turn this sketch into an actual three-dimensional object, kind of like modeling. If you watch my video about the propane tank bracket on how I had modeled. So we're going to come up here and we're going to click Finish Sketch, and then there's hotkeys. You're going to press Hotkey E, which is actually the same as this right here. Well, I'll tell you, I'll just click that. That's Extrude, and you're going to, and how we have it highlighted, that's what we want. That's our plate. You're going to left click that, and then you have the arrow. You can take this arrow and you can move it up, and that's what, if the plate was 2 inches thick, that's what it would look like. Or you can set that to however you want, or instead I'll just type in a 1/4 inch, so 0.25 inches. That's a 1/4 inch, a 1/4 inch, and it's going to come up as a new body. If somebody wants another video on what body and component the difference is, I'll be more than happy to do one. But for right now, we're making a new body. You click down here, you click OK, and there you have it. There is a 3D model of the plate that we measured. So you can, and when I work this little cube up here, I left click it and then I use my thumb wheel. Well, you move the mouse. I have a rollerball mouse just because that's what I like using. That's my personal preference. Each is yours. So now I have a three-dimensional object, a three-dimensional model, so to speak. So that's very nice. You can do a lot of this stuff, and I'm going to go through in another video more about 3D modeling, but this is great. Now you say, well, all right, that's great, Jim. You got a 3D model, but now what can I do with it? Well, you can take this and you can convert it into a G-code and 3D print this object out of plastic. And I'll tell you, that is one thing that has once again really revolutionized the stuff I build, is because first and foremost, I just replaced one of my 3D printers, and I paid all of $150 for it. It prints 7 inches by 7 inches by 8 inches tall. Kind of small. I actually have two printers because I have a larger one and a smaller one. It is an amazing tool. It is absolutely amazing. So I can actually 3D print this out of a piece of plastic. So if you have a remotely complex plate bracket or whatever, you can 3D print it for pennies, for only a couple dollars worth of plastic at the most. And then you can actually have a part so you can test fit it before you cut it out of an expensive piece of metal, or take the time and send this file to be laser cut. So that is an excellent tool. So you can take the time to fine tune your design, make sure it fits right. And then the other thing that I like to use for is I make damn sure that these holes line up, is because I would take a measurement, draw it up, 3D print the piece and lay it up there, and one of my holes wouldn't line up. So then I can go in there and I can measure how much the hole is off, and then I come back into the drawing and I can move the hole, how much I measured, redo the 3D model, and then print it out again for less than $1 worth of plastic until it fits right. And that to me, that saves a lot of time and money, because if you send it out to be laser cut, you're going to wait 2 to 3 weeks. You're going to spend money, because right now when I'm making this video, metal in general is expensive. So I don't like to make mistakes with that. So I've made some very nice brackets where I would print out all the different components of the bracket. I could test fit them all together, glue them together if you have to, bolt it to where it's going to go, and make sure everything fits perfect before you spend the money to get it cut out of steel or metal or whatever you're using. So that is, to me, that is invaluable. But this video is starting to get a little bit long, and but I really just some of that stuff is going to be for another video, and I hope you'll find them find them interesting. So, anyways, but I think it's about time to wrap this up because I'm getting long-winded as it is. I tend to get, like I said, I really enjoy this, and especially, like I said, and if you didn't see my introductory video, the truth of it is, the background I have, I'm not an engineer, I'm not an architect. I mean, I did not go to school for any of this, but the biggest thing is the things I like to do, I found a need, so I searched out the information and learned it. And like I said, learning the CAD right here has been wonders for what I've done and for what I like to do. So, but the biggest thing is I'm hoping I can show everybody is that I mean, this is achievable for about anybody. I mean, you don't have to have massive amounts of education to do this. If you have the desire to learn something, like I said, there's so much knowledge out there that people are sharing. Go get it. I mean, it's out there for you. So anyways, all right, I gotta calm down a little bit. So well, I'm gonna leave it at that. I've shown you how to draw a simple sketch. You can make a simple 3D model, and I've even talked about how that can benefit and how you can use them, from exporting as a DXF file, getting the sketch laser cut, or printing it out on a piece of paper, making a paper template, or making a 3D model out of it and then printing it off, that you can 3D print it off of a 3D printer. So on some of these other options, if you subscribe to my channel and check back and look for future videos, I plan to do videos to demonstrate this, because I stumbled my way through it, and sometimes it would have been a lot easier if someone said, oh yeah, just click this and put this here and your life will be a lot easier, or clean the sketch up before you save it as a DXF. Like I said, I'm going to go over a lot of that stuff, but once again, I hope I can help somebody with a little bit of inspiration on using this to tackle one of the projects they're doing, or do some of the simple things you do. But anyways, I hope you like this video. I hope you found something interesting about it, and I hope I could help you find some inspiration to tackle something more. If you have any questions, feel free to put them in the comments. I will do my best to answer them. I'm going to put in some of the resources and some of the other resources that I have used to learn this. But anyways, so if you like the video, please like it, share it with your friends, and please subscribe to my channel. So until next time, I will see you later. Bye.